Resistors are essential components found in every electronic circuit. They are often overlooked, but they play a crucial role in controlling the flow of electricity. These tiny components are the unsung heroes of the electronics world. Without them, our gadgets would not work. Resistors are designed to resist the flow of electrical current. This resistance is measured in ohms. By adding resistors to a circuit, engineers can control the amount of current flowing through different parts of the circuit. Resistors allow us to create circuits that perform specific tasks. Imagine a water pipe with a valve. The valve controls the flow of water through the pipe. Similarly, a resistor controls the flow of electricity through a circuit. By adjusting the resistance, we can control the amount of current flowing to different components. This control is essential for the proper functioning of electronic devices. Resistors come in various shapes, sizes, and materials. Each type has unique properties and applications. In the following sections, we'll explore the fascinating world of resistors. We'll understand how they work and why they are crucial in electronics. To understand resistors, we need to grasp the concept of resistance and its relationship to voltage and current. This relationship is defined by Ohm's law, a fundamental principle in electronics. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it, and inversely proportional to its resistance. In simpler terms, voltage is the electrical force that pushes electrons through a circuit, like the pressure in a water pipe. Current is the flow of electrons, like the flow of water in the pipe. Resistance is the opposition to the flow of electrons, like the valve restricting water flow. Ohm's law is expressed as V equals Y times R, where V is the voltage measured in volts, I is the current measured in amperes, and R is the resistance measured in ohms. This simple equation tells us that increasing the voltage increases the current if resistance remains constant, and increasing the resistance decreases the current if voltage remains constant. Ohm's law helps us calculate the resistance needed to achieve a desired current flow for a given voltage. It's a fundamental tool for designing and analyzing electronic circuits. The resistance of a material is determined by its inherent properties and physical dimensions. Different materials have different atomic structures, affecting how easily electrons can flow through them. Resistivity is an intrinsic property of a material that quantifies its resistance to electrical current. Materials with high resistivity, like ceramics, are good insulators. Materials with low resistivity, like copper, are good conductors. The resistance of a material also depends on its physical dimensions. A longer conductor has higher resistance because electrons encounter more obstacles along their path. A conductor with a larger cross-sectional area has lower resistance because there are more paths for electrons to flow. These factors are related by the following equation. R equals resistivity times length divided by cross-sectional area. This equation tells us that resistance is directly proportional to resistivity and length, and inversely proportional to the cross-sectional area. By choosing materials with specific resistivities and adjusting their dimensions, engineers can create resistors with precise resistance values for various applications. Section 4: Resistors and Energy Dissipation, the importance of staying cool. When current flows through a resistor, some electrical energy is converted into heat. This process is called Joule heating or ohmic heating. The amount of power dissipated as heat is given by P equals I squared times R, where P is the power dissipated in watts, I is the current in amperes, and R is the resistance in ohms. This equation shows that power dissipation increases with the square of the current and power dissipation increases linearly with resistance. Excessive heat can damage resistors and other components in a circuit. Therefore, thermal management is crucial in electronic design. It involves dissipating heat away from sensitive components to maintain a safe operating temperature. Heat sinks, fans, and other cooling mechanisms are often used to prevent overheating. Engineers also consider the power rating of resistors, which specifies the maximum power they can safely dissipate without damage. Section 5: Types of resistors and their applications, a world of choices. Resistors come in various types, each with unique characteristics and applications. Some common types include carbon composition resistors, which are made from carbon mixed with a binder. They are inexpensive and widely used in low-power applications. Carbon film resistors consist of a thin layer of carbon deposited on a ceramic rod. They offer better stability and accuracy than carbon composition resistors. Metal film resistors use a thin film of metal alloy deposited on a ceramic substrate. They provide high accuracy, low noise, and good temperature stability. Wire wound resistors are made by winding a resistive wire around a ceramic core. They can handle high power and offer excellent precision. Choosing the right type of resistor depends on the specific application's requirements, including resistance value, power rating, tolerance, and temperature coefficient. Tolerance indicates the permissible variation in resistance from the specified value. Temperature coefficient measures how much the resistance changes with temperature. Resistors are essential in various electronic circuits, including voltage dividers, which divide a voltage into smaller parts, current limiting, which protects circuits from excessive current, timing circuits, which create time delays and oscillations, and filtering circuits, which block unwanted frequencies. Resistors, in their various forms, are the unsung heroes that make our electronic world possible. Their ability to control current flow, dissipate energy, and maintain circuit stability makes them indispensable components in countless applications. As technology advances, the role of resistors will continue to evolve, shaping the future of electronics.